Hello students, this is Mrs. Raposa. So we're coming down to one of our last few assignments of the school year. In this lesson, you'll be using trig identities to solve trigonometric equations that are a little bit more difficult. But we know that you're up for the challenge. You guys have been doing fantastic work even throughout all this remote learning. Miss Vanessa and I have expressed many times how well you're all doing. So keep it up just a little while longer. And don't forget, you can contact your teacher for help, or better yet, join a Google Meet. The weather's getting really nice. Take your device outside and your work outside and join the Google Meet from outdoors. That's always a nice alternative, but I encourage you to keep doing your best and finish the year strong. Okay, let's do some examples. Okay, so let's start by solving example 1. We need to solve the equation 2 times the sine squared of theta minus 1 equals 0. Remember, we're solving for theta. We're trying to find what angle measure makes this true. We want to find all the angle measures between 0 degrees and 360 degrees that make this true. Okay, there's infinitely many angles, but we only want the ones between 0 and 360. So what I'm going to start to do to get sine squared theta alone is start by adding 1 to each side. If I add 1 to each side, I'll get 2 times the sine squared of theta is equal to 1. I'll cancel that out, add 1. Now I need to divide each side by 2 to get rid of 2 times sine squared theta. Divide by 2, and I'll get sine squared theta equals 1/2. Okay. Now what I need to do is undo the sine squared. And to undo squaring, you square root. So I'm going to take the square root of this side, and I'll end up with sine theta. So sine theta is going to equal either the positive square root of 1/2 or the negative square root of 1/2. I'm going to show you both of them. So it either equals positive square root of 1/2, which by the way is equal to root 1 over root 2. When you rationalize the denominator, you end up with root 2 over root 2 times root 2 is 2. So sine theta equals root 2 over 2. Remember, I also want to take the negative root, so I'm going to solve both of these equations. Sine theta can also equal negative root 2 over 2. Okay, so I'm going to solve both of those. Let me get rid of all of this, so I'll just leave it as root 2 over 2. Hopefully you know by memory which angle measure has a sine value of root 2 over 2. That's 45 degrees. But remember, you can always go to the calculator and do the sine inverse of root 2 over 2, and you'll also get 45 degrees. Remember, that is a quadrant 1 angle. So 45 degrees right here. Remember, we want to find all angle measures that have a sine value of root 2 over 2. Sine is positive in quadrants 1 and quadrant 2. So I want to find this angle as well, which is going to be 180 degrees minus 45 degrees. And 180 degrees minus 45 degrees is 135 degrees. So those are the two solutions that make for angle measures that make sine of that angle measure equal to positive root 2 over 2. And let's find the two that make sine of that angle measure equal negative root 2 over 2. Remember, sine is negative in quadrants 3 and 4. My circle doesn't look all that great, but I think you get the idea. The quadrant 3 angle is going to be 180 degrees plus 45 degrees. That sine value will be the same there. And 180 degrees plus 45 degrees, that's going to be 225 degrees that make this equation true. And we'll also have a quadrant 4 angle. Now, if you do sine inverse of negative root 2 over 2, you're going to get an angle measure of negative 45 degrees, which is really here. But remember, we want positive angle measures between 0 and 360. So what I'm going to do is I'll do it 360 minus 45 degrees, and that'll give me a 315 degree angle. So those are the 4 angle measures that make this equation true between 0 and 360 degrees. Okay, let's do example 2. This one's a little bit more involved. We're actually going to do this by making a substitution for cosine squared of x, and then what we end up with is something in quadratic form, and then we'll solve by factoring. So let's go ahead and replace this cosine squared of x with its identity, which I'm going to put in red here. Remember that sine squared of x plus the cosine squared of x is equal to 1. And there's my cosine squared of x. And I can get that term alone by just subtracting sine squared of x from both sides. And when I do, I'll end up with cosine squared of x is actually the same thing as 1 minus the sine squared of x. And the reason I want to do that is because everything's in terms of sine here. That's why it's kind of helpful. I want to get everything in terms of sine of x. So I'm going to replace cosine squared of x with 1 minus the sine squared of x. So I'm making a substitution here based on the Pythagorean identity. I'm going to get rid of this to make room to work. And now let's solve this equation, which probably doesn't look any much easier, but if I get one side, this side equal to 0, it's going to help. So what I'm going to do is to get this side equal to 0, I need to subtract 1. There are no like terms here, so I'm just going to put minus 1 at the end. And add sine squared of x to both sides of the equation. That is a like term with this one, so I'm going to add to this sine squared of x, I'm going to add another sine squared of x. And when I'm all done, I end up with this new equation, 2 times the sine squared of x, as I have 2 of them, minus the sine of x, minus 1 is now equal to 0. You may not recognize it, but this is actually quadratic form. I have sine squared, a sine, and a constant term. And just to make it a little bit more noticeable that it's in quadratic form, I'm going to make what's called a u substitution. I'm going to replace every sine of x. I'm going to replace it with u. So I'm going to let u equal the sine of x. Let's make this a little clearer. So everywhere I see sine of x, replace it with u. Remember, this is sine of x squared. So this is really 2u squared. And replace the sine of x with u, minus u, and then minus 1 equals 0. And now you can definitely see it has quadratic form. So what I'm going to do is I'm going to solve this by factoring. This is actually factorable. So I'm going to find the two factors that multiplied together give me 2u squared minus u minus 1, set it equal to 0, and then I can set each factor equal to 0. 2u squared, 2 is a prime number, so the only way to get that, I'm going to do the guess and check method here, is 2u times u. My constant terms in each set of parentheses, when I multiply them, have to give me a negative 1. So I know right away one's going to be positive and one's going to be negative. What I don't know if it's positive negative or negative positive. But the only way to get negative 1 is to do negative 1 times positive 1. So is it negative 1 and positive 1? Or is it positive 1 and negative 1? And if you guess and check and FOIL them out, you'll see 2u, remember I need to get a negative 1u in the center. 2u times negative 1, that will give me negative 2u. And this one in the center will be positive 1 times u. And just to double check, to make sure that that does check out, I can actually check it here. When you do first, outer, inner, last, first will be 2u times u. Outer will be 2u times negative 1. Inner will be 1 times u. And last will be negative 1. And as you can see, negative 2u plus u does combine to give me negative u. So that does work. I'm going to get rid of it. That was just my check. Now let's set each one of these two factors equal to 0. So either 2u plus 1 equals 0, or u minus 1 is equal to 0. Let's get u by itself first, and then I'll replace it back with sine of x. So I'm going to first subtract 1 from each side, and I get 2u equals negative 1. Divide by 2, and I get u equals negative 1 half. On this side, if I add 1 to both sides, I'll get u is positive 1. So remember, our u is really sine of x. So replace this u with sine of x over here. And I'll have sine of x is equal to negative 1 half. I need to find out what angle measures make this true, negative 1 half. And now I need to say u is equal to 1, but u is really sine of x. So let's solve this equation also. Sine of x equals positive 1. Let's find the angle measures that make this true. Sine of x equals negative 1 half. You can put that into your graphing calculator, and you'll get that the sine inverse of negative 1 half is actually negative 30 degrees. And negative 30 degrees is first of all, it's in degrees, we want it in radians, but we still don't want anything that's in, we still don't want anything that's negative. So I want all positive angle measures. So negative 30 degrees would be down here, right? So negative 30 degrees, but I want a positive angle measure. Well, negative 30 degrees is going to have a sine value of negative 1/2, but so is 360 minus 30 degrees. So 360 degrees minus 30 degrees, that's going to give me 330 degrees. And I want my angle measures in radians. This is 11 sets of 30 degrees. So that's 11 sets of pi over 6. So 11 pi over 6 is one of my solutions. Sine value is negative in quadrant 4 and in quadrant 3. To get the quadrant 3 angle, I'm going to do 180 degrees plus 30 degrees, and that'll give me 210 degrees. This is 7 sets of 30 degrees, so 7 sets of pi over 6 is my other angle measure. Those two angle measures, when you take their sine value, you'll get negative 1/2. But remember, another solution is the solution to this one. Sine of what angle measure is 1? Remember, sine is our y coordinate. Well, the sine of 90 degrees is actually 1, because that's the y coordinate up here. 90-degree rotation will land me at this spot, 0, 1. So I know that my x can also be 90 degrees. But again, I want my angle measure in radians, and 90 degrees is the same thing as pi over 2 radians. So the three solutions between 0 and 2 pi to the equation that we originally had, which was sine squared of x minus the sine of x equals the cosine squared of x. Your three solutions to this equation between 0 and 2 pi are 11 pi over 6, 7 pi over 6, and pi over 2.